Welcome to the analysis module of our experiment. Here we're going to be learning about the time and space complexity of merge sort. Then we're going to look at how merge sort is a stable sorting algorithm, and later we're going to try to compare it with other algorithms to get a better overview. First, let's see the time complexity of merge sort. We are now familiar with the merge sort tree. So let's assume that the initial array that I have is of n elements. For simplicity, let's assume n is a power of 2, say 2 to the power k. I call the first level as level 0. So at level 0, I have one array which has n elements, which is equal to 2 to the power k elements. At level 1, I'm going to have two arrays of n by 2 elements each. Similarly, at level 2, I'm going to be having 4 arrays of n by 4 elements each. If we try to generalize this, we can see that at level z, I'm going to be having 2 to the power z subarrays of length n upon 2 to the power z elements each. Make sure you understand this step before we proceed to the next part. Now that we have established that we have n upon 2 to the power z elements at level z in each array, let's get back to our merge sort tree. We know that we stop the split step when we have subarrays of size 1 each. So say this level is level L. At level L, I can say that I have n upon 2 to the power L elements in each subarray, which in this case turns out to be 1, since these are single elements. By here, looking at this, I can say n is equal to 2 to the power L. Remember how we did the logarithm during recap. From this equation, I can say that L is equal to log n to the base 2. Since L is the last level and I'm starting from level 0, I have a total of L levels in this merge sort tree. By now we have established that in the merge sort tree, we're going to have L levels where L is equal to log n to the base 2. Now let's see how much time we take at each level. At each level, after splitting, we move on to the merge step. So we see that while merging, say I have to merge subarray 1 and subarray 2. I maintain 2 pointers and I iterate through each of the subarrays exactly once to reach the end. When I'm done iterating through both the arrays, I have my final sorted array right here. So say this subarrays of L elements, this subarrays of L elements. To iterate through this subarray, I take O of L time. To iterate through this one, I take O of L time. And in total, at this level, to merge these two arrays, I'm going to take O of L plus O of L, which is equal to 2 into O of L time. Let's get back to our merge sort tree. So at this point, say at this level, we can see that we're going to be merging arrays of length 2, and we're going to be doing the same thing 4 times. So we're basically going to be merging with the time complexity O of n by 4 plus n by 4 plus n by 4 plus n by 4, which turns out to be O of n. At each level, we can see the same thing. Here, the time complexity will be
O of n by 2 plus O of n by 2,
which will be equal to O of n. So we can notice that at each level, the time complexity for merging the arrays is O of n, and in total we have O of log n levels. So we can say that total time complexity equal to O of n log n to the base 2, because I have log n to the base 2 levels into n, which is the time complexity for merging at each level.